So I'm just going to assume that we did not get to this yesterday. If we did, you can just skip ahead. Um, but I'm doing this the night ahead, so I'm going to assume that we didn't. If we did, just skip ahead, like I said. Um, so E is just a number. It's such a special number in exponential relationships that it kind of like pi is for circles. So you can think of E for exponentials as pi for circles. So pi is 3.14 approximately, where E is approximately 2.718 or 2.72. And for graphing purposes, we'll even say it's 2.72 approximately. So it's just a number, but it's such a special number that it's given a quote unquote variable, even though it's a number. It's not a variable because variables change. So, okay, so remember E is a number. So we have two charts. We're going to start with our parent, which would just be e to the x. So we have our x, and then our y equals e to the x. So we're going to start with our typical x values, -1, 0, and 1. And since e is 2.72, we can use our calculator for this. And we're going to be using non-graphing at least for this. 2.72 to the -1 is about 0.37, and you can check that in your calculator. If you plug it to the power of 0, it's still 1, and then to the power of 1 is 2.72. So these are always going to be your parent points for your e to the x graph. And then just like your other graphs, you apply your transformation. So we have a horizontal reflection or reflection over your y-axis, and then a vertical shift up 2. So our x values change in sign, and then our y values go up by 2. So everything adds to 2, which means that our asymptote, is right here, is going to go up by 2. And remember, that's the first thing you want to graph. Always the first thing you want to graph. Domain is always going to be the same for exponentials, which is really nice. And the range is determined by the fact that your asymptote, right, is determined by your asymptote. And then you want to make sure it didn't reflect vertically. If it did not reflect vertically, you're going to stick with your asymptote to infinity. If it did reflect, then it's your negative infinity to your asymptote. Your y-intercept, you can see here, you already have the value, so you don't have to plug it in. So it's 3, because it's 0, 3. And then we'll go ahead and plot our points. So we have 1, 2.37, 0, 3, and then -1, 4.72. So notice how it's decreasing because of the horizontal reflection. Because 2.72 was bigger than 1, so it would have been growing, but that negative exponent made it decrease. Okay. So there's a couple more practice items for transforming graphs, and you can go ahead and practice those and check the answers. All the notes, filled notes, are on Canvas. So if you wanted to practice those, you can try those and then check them on Canvas. I'm going to skip ahead to a new concept called compound interest formula. And this is super easy to work with once you have the formula, and you will be given these formulas, but you do have to know what the pieces in them stand for, or else you won't know how to use them. So the formulas you'll be given, the pieces in them you'll have to know. So the compound interest formula is typically used to use for exponential growth of money. So you have your final amount, and that's what that is, the total amount of investment. Then you have your principal amount, which is your initial amount. So that's here. And then you have, so that's like your kind of your y-intercept, like we said. And then you have your multiplier, and your multiplier consists of a couple different components. So basically you have 1 plus your rate over n, and n is the number of times that your interest is compounded per year. And I'll explain that. And then to the power of the number of compounds is the number of years. So this is your multiplier here. And the reason you add it to 1 is because you want to add it to 100% of your money that you have already. So you're adding your interest to what you already have. And that's what that is when you add it to 1. Okay, because think about 100%. The rate of 100% is 1. Okay. And then T is time in years, R is interest rate in decimal form. Okay, so here's an example with actual numbers, so it might make a little bit more sense. So find the final amount of $500 investment after 8 years, 7% interest. By the way, that's insane. If anyone tells you that amount of interest, take it or don't believe them because it might be fraud. But 7% is insane. 7% interest compounded annually, quarterly, and monthly. So there's different phrases. Annually is once a year. Quarterly is 4 times per year. So think of quarters. Monthly is 12 times per year. That makes sense. Whoops. And then there's such a thing called semi-annually, and that's 2 times per year. So just a couple things to look out for. So what that means is that your interest is divided. So if it's 7%, it's divided over 4 times per year. So it's put towards your money 4 times. The 7% is divided and then put towards your money 4 times per year. So when you're dealing with it annually, you just take your 500 and you do your 1 plus, because that's your decimal of 100%, plus your rate, which is 0.07 over 1 to the power of 8 times 1. So really, when it's annually, you don't need all this. It really just comes out to 500, and then your multiplier is 1.07 because you're adding 7% to 100%. So your rate would be 1.07. That makes sense, right? 107%. So when it's annually, it's pretty straightforward. Just your multiplier is 1.07, 8 years, here's your initial, and then you're plugging in. Okay. And that comes out to 859.0. So I'm not going to plug all these in. I'm going to have you do that and you can check with the people around you, but we'll go through how to actually use it and then you can plug it in. Quarterly, so this is a little bit different. You won't see the 1. Where you see this one, you'll see a 4. This one you'll always see here because that's like 100% of your money. So we're taking 7% rate, but we're dividing it by 4 because it's 4 times per year. And then your exponent is going to be 8 times 4. I'm going to do that down here because I want you to make sure that your exponent is simplified. So your exponent is 32. So there's a total of 32 times that your interest is put towards your money. And then you literally just plug it in as you see it in your calculator. And I'll just make sure and confirm that you're getting what you need to. You should be getting $871.11 if you're rounding. Okay. And then monthly is 500. And then 1 plus 0.07 divided by 12 times per year. And then your exponent is going to be 8 times 12. So that's going to be 96. Okay. So that's compound interest. Pretty straightforward, especially when you have the formula. Okay. I'll give you this last one too. Oh, well, let's give that answer to you. Hopefully you're plugging this in, not just having me do it for you. Okay, so that will give you 873.91. Notice how the money is slightly going up the more compounds you have. So it's not much, but you want more money is more money, right? So the more number of compounds, the more money you make.